Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
A study published in Science Advances by an international team of scientists provides clear evidence that marine phytoplankton are much more resilient to future climate change than previously thought. Combining data from the long-term Hawai'i Ocean Time-series program with new climate model simulations conducted on one of South Korea's fastest supercomputers, the scientists revealed that a mechanism, known as nutrient uptake plasticity, allows marine algae to adapt and cope with nutrient-poor OCE. Phytoplankton are tiny algae which drift at the ocean surface and form the basis of the marine food web. Knowing how marine algae will respond to global warming and to associated decline of nutrients in upper ocean waters is therefore crucial for understanding the long-term habitability of our planet. The latest report of the Intergovernmental Panel on Climate Change, IPCC, states an uncertainty of -20% to +20%, which implies an uncertainty as to whether phytoplankton will increase or decrease in future. Global warming affects the upper layers of the ocean more than the deeper layers. Warmer water is lighter and hence the upper ocean will become more stratified in future, which reduces mixing of nutrients from the subsurface into the sunlit layer, where phytoplankton reside. Earlier studies suggested that the expected future depletion of nutrients near the surface would lead to a substantial reduction of oceans' phytoplankton production with widespread and potentially catastrophic effects on both marine ecosystems and climate. But according to a new study in Science Advances, this may not happen. New analyses of the upper ocean phytoplankton data from Hawai'i Ocean Time-series program shows that productivity can be sustained, even in very nutrient-depleted conditions. On a community level, one might see further shifts towards taxa that require less phosphorus, says David Carl, a co-author of the study, professor in oceanography at the University of Hawaii and co-founder of the Hawai'i Ocean Time-series study program, to illustrate the concept of phytoplankton page. To study how this unique metabolic hack will impact global ocean productivity over the next few decades, the team ran a series of climate model simulations with the Community Earth System Model, version 2, CESM2, on their supercomputer Aleph. By turning off the phytoplankton plasticity in their model, the authors were able to qualitatively reproduce previous model results of a decline in global productivity by about 8%. However, when turning on the plasticity parameter in their model, in a way that captures the observations near Hawaii for the past 3 decades, the computer simulation reveals an increase in global productivity of up to 5% until the end of this century. Inspired by the results of their sensitivity computer model simulations, the authors then looked at 10 other climate models, whose data were used in the recent 6th assessment report of the IPCC. The results confirmed the authors' initial conclusions. Models without plasticity tend to project overall declining primary production for the 21st century, whereas those that account for the capability of phytoplankton to adapt to low nutrient conditions show on average increasing global productivity, says Dr. M.G. Even though our study demonstrates the importance of biological buffering of global-scale ecological changes, this does not imply that phytoplankton are immune to human-induced climate change. For instance, worsening ocean acidification will reduce the calcification rates of certain types of phytoplankton, which can lead to large-scale shifts in ecosystems, warns Dr. Eun-Young Kwon. These factors are neither well understood nor represented yet in climate models. Future Earth system models need to use improved observationally based representations of how phytoplankton respond to multiple stressors, including warming and ocean acidification. This is necessary to predict the future of marine life on our planet, says Professor Axel Timmermann, a co-author of this study and director of the IBS Center for Climate Physics. Science Advances, 2022. 8, 51. doi. 10. 1126, Sci-Adv. Ad 2475 Institute for Basic Science. Metabolic hack makes ocean algae more resilient to 21st century climate change. Science Daily. https://ift. tt. wsys 590. Access December 21, 2022. Thanks for watching. Please subscribe my channel for more videos.